Welcome! In this video, we are going to explore the classic n-queens problem using recursion and backtracking. Let's find out what this challenge is all about. The n-queens problem consists of placing n-queens on an n by n chessboard in such a way that no two queens threaten each other. That means no two queens can be on the same row, on the same column, or on the same diagonal. The goal is to find all valid configurations that satisfy these conditions. For example, if n equals 6, we must place 6 queens on a 6 by 6 board without conflict. To solve this problem, we use a technique called backtracking. We place a queen, check if it's safe using a validation function, and if it is, we continue. If it's not, or we reach a dead end, we'll backtrack, removing the queen and trying another position. This process continues until our queens are safely placed. Our journey begins in the main method. First, we define the size of the board with the variable m. Then, we create a matrix of size n by n to represent the board. We initialize the board with zeros using the inicializar tablero function. And finally, we call the recursive function colocar reinas tablero 0 to start placing queens row by row. This is the heart of algorithm, the recursive method. First, it checks the base case. If we've placed a queen in every row, it means we've found a solution and the board is printed. If not, the function tries every column in the current row and checks if placing a queen is safe. If it is, it plays the queen and calls itself recursively to continue with the next row. If not, it removes the queen and tries the next column. And now, let's go step by step through the recursive execution flow. Method call at row 0, we start with an empty board and position ourselves at row 0 since no queens are placed yet. Initial is safe. We use the seguro function and place the first queen in the column 0. Method call at row 1. We move to row 1 and start checking column by column. Column 0 is directly below the first queen, so it's not valid. Column 1 is on the diagonal of the first queen, also invalid. Column 2, however, is safe, so we place the second queen there. Method call at row 2. We continue with row 2, columns 0, 1, 2, and 3 are threatened by previous queens. Column 4 is the only safe one, so our third queen goes there. Method call at row 3. We move down to row 3 and validate. Column 0 is threatened by the first queen, but column 1 is free, so we place the fourth queen there. Method call at row 4. We proceed to row 4 again. The first columns are threatened. Eventually, we find a safe position in column 3 and place the fifth queen there. Method call at row 5. We reach row 5, but all columns are threatened. We can't place a sixth queen, so we apply backtracking. Return from method row 5 to row 4. We remove the queen from row 4 and try the remaining columns. No other safe option. Return from method row 4 to row 3. We remove the queen from row 3 and try new position, but all are threatened. Return from method row 3 to row 2. We remove the queen from row 2 and look for a new spot. We find a safe position in column 5 and place the queen there. Method call at row 3. We check column 0, but it's threatened. Column 1 is free, so we place the fourth queen there. Method call at row 4. We go down to row 4, but using seguro, we see that our columns are threatened. Return from method row 4 to row 3. Back to row 3, we remove the queen and continue checking for safe position, since there are no more options. Return from method row 3 to row 2. We were already on the last column. Return from method row 2 to row 1. We move the queen to the next safe spot, column 3. Method call at row 2. Column 0 is threatened, but column 1 is safe, so we place our third queen there. mirror call at row 3. In row 3, we check columns and find column 4 is safe, so we place the 4th queen there. Mirror call at row 4. We move to row 4 and column 2 is safe, so the 5th queen goes there. Mirror call at row 5. Next row, row 5, but no column is safe. Return from method row 5 to row 4. We remove the queen and check the rest of the columns, no safe position. Return from method row 4 to row 3. We remove the queen and look for another position, no options. Return from method row 3 to row 2. We move the queen to column 5, which is safe. Mirror call at row 3. We check columns and place the queen in column 2. Mirror call at row 4. However, in row 4, no position are safe. Return from method row 4 to row 3. We remove the queen from row 3 and check for another safe position. Nothing. Return from method row 3 to row 2. We were already at the last column. Return from method row 2 to row 1. We move the queen to column 4, which is safe. Mirror call at row 2. We place the queen in column 1, which is not trident. Mirror call at row 3. We go through our columns until we find column 5, which is safe. Mirror call at row 4. We find column 2 is free and place our queen there. Mirror call at row 5. In row 5, a column is available. Return from method row 5 to row 4. We remove the queen and check the remaining columns, all are trident. Return from method row 4 to row 3. We check the last column, all trident. Return from method row 3 to row 2. In row 2, no column is available. Return from method row 2 to row 1. We move the queen to the last column. Mirror call at row 2. Column 0 is trident, but column 1 is safe, so we place the queen there. Mirror call at row 3. We place the queen in column 4, which is safe. Mirror call at row 4. We try to place the queen, but all columns are trident. Return from method row 4 to row 3. We check the last column, all trident. Return from method row 3 to row 2. We move the queen to the next safe position, column 3. Mirror call at row 3. We place the queen in column 1. Mirror call at row 4, but in row 4 there are no safe positions. Return from method row 4 to row 3. We remove the queen from row 3 and discard the rest of the columns. Return from method row 3 to row 2. We remove the queen, no safe position. Return from method row 2 to row 1. We remove the queen and no more columns available. Return from method row 1 to row 0. We move the queen to column 1. The mirror call at row 1. Column 0, 1 and 2 are not safe, but column 3 is. Mirror call at row 2. Column 0 is safe, so we place the queen there. Mirror call at row 3. For row 3, safe position is column 2. Mirror call at row 4. The only safe position is column 4. Mirror call at row 5. In row 5, no position is safe. Return from method row 5 to row 4. We check the next column, is trident. Return from method row 4 to row 3. We iterate through the columns, no valid options. Return from method row 3 to row 2. We move the queen to column 5. Mirror call at row 3. We place the queen in column 0. Mirror call at row 4. Column 0 and 1 are trident, but column 2 is not, so we use it. Mirror call at row 5. Column 0, 1, 2 and 3 are not safe, but column 4 is. Mirror call at row 6. Row 6 equals n. We've successfully placed 6 queens the board with the first solution is free. Even though the code is currently implemented, there are certain values of n, such as 2 or 3, where the n queens problem has no valid solution. This means it's impossible to place n queens on a n by n board without them attacking each other. In this case, the program executes normally, but never reaches the base case of the recursion, so no solution is print. This doesn't indicate an error in the code, but rather that the problem itself has no solution for those specific values, making them invalid instance. Thank you for watching. We hope to help you understand how recursion and backtracking work to solve the n queens